June 7th. We're all here for a good evening tonight, yes? Come on, yes! Hey! That's what we'd like to see. A bit more of that. June 7th, 2017. Thanks for all for coming this evening. Hang on. So, quick thank you to our sponsors who made this happen this year. So tonight from our sponsors we have somebody from Commvault, Peter, Chris doing the talk, and we also have Peter from a Cloud Guru doing the talk. So thank you to our sponsors who make this happen and help us to make this happen on a monthly basis. So round of applause for them. Thanks everyone. So tonight the structure is same as most months. We have a lightning talk from David and Vinci from PolarSeven. Who'll give you some updates. And then we have Peter from a Cloud Guru. Then we're going to have a break for networking and pizzas. And then we'll have Chris from Commvault give us a talk about journey to the cloud from backup and archive to the cloud. Everyone here heard of Commvault? Yes? Yes? Cool, thank you. Told me to dig in. So for recruitment, so Kev, who's floating around, Kev, where are you? He's hiding somewhere. He's over there. So he's looking for heads of engineering, a Windows specialist, and a cloud engineer. So if you're looking for a role, then talk to Kev over there. So up next we have David and Vinci from PolarSeven, who are going to give a bit of a talk on updates and news. So David, I'll hang over to you.
Thanks, Darryl.
No worries. Wireless technology.
Wow, what a crowd. Okay, well, I'm going to start off with 5 minutes on some new aspects to Amazon Web Services, and then I'll give a 5-minute introduction to SSL certificates, IAM and ACM. Now, you may remember, I think it was last time, or maybe the time before, I gave an introduction to EFS, the Elastic File System, and Vinci will be giving you a deeper dive into that, basically war stories of the trenches. So I'll start off with...
Sorry, can you guys hear it on the back? Do we need to turn it up? It's good?
Good.
Yeah? Okay.
I'll start off with what's new in AWS. So first thing will be auto-scaling. So there's now resource level permissions on auto-scaling. Now, I know that doesn't sound very sexy, but what this means is, say you're in a large organization and you've got a large group of developers, you want to control how much infrastructure that they can create. And so you can use, next slide. So what you can do is now is in the IAM, you can say create a developer group, and then you can attach policies to that group. Now, as you can see, the action here is any auto-scaling. You can control the size, minimum and the maximum size, and you can also control like the instance type, and you can also control what tagging they put on there. Now, especially in larger organizations, tagging is very important. And if you're using a third-party software like, let's say, Cloud Health, then tagging is great for figuring out what's costing you money. So you can force developers to put tagging onto the instances that they're creating for auto-scaling. Next thing. Okay, CodeCommit, and this has been out for a while, but it's only now released in the Sydney region. It's basically GitHub in Amazon. So you've got built-in highly redundant and durable architecture. You store code binaries, images, and libraries. Encrypted and transiting REST, works with existing Git tools and webhooks. This is basically GitHub, but it's integrated with IAM. So that means you can control specific repositories through IAM. You pay per user per month, and that's $1 per user per month. You get 10 gigabytes and 2,000 commits per month. Now, the thing about IAM is that, as you know, with GitHub, you need to have SSH. So you can store those SSH keys now in IAM. and you can get those through a command line call. In this case, it's get SSH key. Now, I won't go into this now, but I may get to talk on this later. That has got some amazing possibilities. So you can go and grab a PEM file through the CLI.
Sorry, who here is using GitHub? Who's using Bitbucket? Who's using CodeCommit? Okay, we need to change that a bit.
Okay, Amazon Inspector. And this is an automated security assessment. It's available on most Linux platforms and Windows. So what it basically does is that you install an agent on those instances, and then through various policies and through the console, you can control the information you're getting from those agents. Use templates and rules to configure the agents, and then you can use tagging on the agents to group assessment targets, apply rules to that group, and then you can get the rules can be updated regularly. Now, as you know, with this sort of intrusion detection, a lot of the information you're going to get is from outside. Import that in. So you can use Center for Internet Security benchmarks. You can enforce security best practices like SSH version 2 only, no root access, whatever else you may want to put on there, and runtime behavior, unused listening reports. So there's quite a lot of things that you can do with this. So in a large organization, you get a nice control over security.
Is that a global service or is that a breach-based service? As in, is it available to?
Yes, yes. Everything tonight is available in Sydney. Yeah. Okay, so that's it for what's new. So we're going to go on to SSL certificates, the IAM and CM. Now, you will be familiar, most will be familiar with SSL certificates, and that you have to go and get an SSL certificate, and you've got different types of SSL certificates. You have extended validation, or domain validation, or self-signed. So if you want to, you can go and get your certificate, and you can import them into the IAM and use those in your auto-scaling groups, or you can use them like an Apache host file. Or you could use ACM, Amazon Certificate Manager, and they will generate a domain-validated certificate for you, not an extended validation. So you get the domain validation. They will generate that for you. They will keep that in ACM, and it will automatically renew. So really, you can set and forget. However, there are a couple of limitations with the ACM. You can only use them with the Amazon resources. So you've got ELB, CloudFront, APN Gateway, and Elastic Beanstalk. But if you're not using ELB, most of you would be using ELB. So you can go into your ELB listener, port 443, and you just drop down, you select your either your ACM or your IAM certificate. Now, with the ACM, they are auto-renewing. With the other ones that you import, they are not auto-renewing, but you can go into the IAM, the CLI, and list all the certificates you got there and all the expiry dates. So it's pretty easy to get that sort of information. To enter the your certificates into Amazon, you had to do it through the command line. There's no console access unless you're on your load balancer and you get the drop down. You do have the option of importing a certificate, and this little page comes up, and you just cut and paste the keys in, say it's done. Easy peasy. That's probably about it for me. I think I've, yeah, there we are. That's my last slide. There you can see here the options you've got. You can either use the ACM, the IAM, or import. But I didn't put the next slide on there. And here you can list your certificates. Either it'll have it here with either the IAM or the ACM. Okay, so I'll hand the mic over to Vinci, and he'll talk about EFS in a little more depth.
Thank you, David. I would rather operate myself. thanks, guys. And I believe last month, if you were here, you've already listening, David, about the EFS availability in Sydney. News for those who were for quite a while. And today, actually, I'm not going to talk about how good this product is. As a technical forum, I'm going to be very objective because we were like one of the first users in this region to deploy it in production environment. So what we did actually was a migration project. We migrated WordPress sites from local disk. So we want to enable auto scaling and we need a shared storage. So you definitely can come up with other solutions like Cluster FS, for example. How many of you are using Cluster? And how many of you, sorry, before I move on, do you guys know what EFS is? Maybe I jumped too fast. So it's Elastic File System, and it's a managed service for this file system. And for those who are looking into re-architect your application into stateless mode, this will be very helpful. Again, this is not like a marketing message. So I really would recommend you guys plan ahead if you do have a plan to try out Elastic File System to plan a POC. That's actually necessary because once you look into the category, you actually have two options when you provision an EFS, either a general purpose or a max IO. I'll explain a little bit more what does that mean. And the general purpose usually had, sorry. Oh, it's a shared storage for multiple instances. So if you have like 2 instances serving as one application bubble and they need to share some data, because EFS can only be mounted to one of the instances, so you need a shared storage. Yeah, and S3, as you may know, is not regarded as a file system. You need some other glue layer to make it, mounted to your local. S3FS, I'm not going to comment on that, and that's another project. But essentially, the point here is before you make any technical decision, I would recommend you do a POC to understand the restrictions and the limitations. So general purpose, usually, sorry, it's a file system. It's a file system. It's not object store. It's not block store.
It's an NFS. It's a shared NFS storage across multiple availability.
Yeah, it has a in Sydney we have 3 AZs, so it's across 3 AZs. 2 zone failures. And again, so general purpose is of lower latency, but it has a limitation of the number of IOs. If you're gonna mount the shared storage to multiple instances, eventually you're gonna hit a limit. So better to understand what limit is. And the max IO gives you the maximum capability to mount to more a higher number of instances, but it has a higher latency. So you really need to understand the use pattern, what kind of read-write pattern you'll be experiencing before you make it. Because once you choose one of these, you can't change. So it's a decision to make at the beginning because AWS does not allow you to change that later. If you figure out you're running out of IO limit, then you have to move your data over, and I'm going to talk about that a little bit later because moving data will be a pain. So data shipping will take time. That means if you initially migrate data, I'll get back to you later. Sir. If you migrate data into EFS and the data sits there and your application is reading from EFS, that's probably okay, but refrain from moving significant amount of data like frequently. So if it's a one-off migration, it's probably okay to do that before you are serving as production. And metadata operations such as disk use, query the disk use, it'll take quite a while if it's a very big chunk of data. And Another example is change ownership. I did a change ownership on a 10 gig directory, and it took me a few hours. You can imagine that. So apparently it's not designed for such operation. Be aware. So bandwidth is determined by your usage. That means if you provision so you pay as you go. If you have 10 gig of data, you only pay 10 gig. The rate is like 36 cents per gig per month, 3 times compared to the EFS SSD, because essentially you pay for multi-zone. But the thing is, your bandwidth is actually determined by your usage. That means if you require a higher bandwidth, you need to fill in some more dummy data. That's what I did. And you also need to pay attention to burst credit, because by default, your persistent bandwidth is determined by your usage. For example, if you have 100 gigabyte data, then the bandwidth is 5 megabytes per second. But you got the ability to burst up to 100 megabytes for 1.5 hours out of 24 hours per day. And that's determined by your credit. So if you use up your credit, that means your bandwidth is capped at 5 megabytes per second. And this might not be something desirable. And you also need to keep an eye on I/O limits. I do have some diagrams, charts from CloudWatch to show you in the third page. The next page is say yes or no. If you're gonna use a stateless app, and if you're not looking for encrypted at rest, yes, I think in general EFS is the choice, because you can move away from managing your own distributed file system like Lambda. You don't have to pay for EC2. You pay as you go. You pay for what you use. That means you're moving away from the management overhead. But if your use case is really shipping data across different storage storage targets, or you move data from S3 back to EFS, or you move one EFS to another, this probably is not the right use. Apparently, if you have smaller size files, but a bigger number, then you need to think twice, because I think in general all distributed file systems are designed for larger files. Because the chunk size, I believe, because I didn't write the code, but I believe it must be larger than 1 megabyte. So if you have like 10,000 of files with a 10 KB in size, the performance definitely is not going to be hitting your target. Well, so that's the fun part. This chart is captured from CloudWatch. If you couldn't see, I'll read it for you. It's percent IO limit. So that's one metric out of EFS from CloudWatch. What does it mean? You are given a limit for general purpose EFS. General purpose, because max IO is kind of a limit. You care about IO limit. But if you choose general purpose, you need to watch the range of IO limit. If it constantly stays at 100, then you got a trouble. Switch to max IO. This is a burst credit balance. It starts with like 2.2 terabyte, and as you can see, it's calculated at real time, like once every minute. So what you want to do is you want to keep them at a very high level, so you can still have the capability of bursting to 100 megabytes per second. So what I did was because they will not be, but they can add to your credit. That's all I did. So overall, EFS is a very good service, but you need to understand it to figure out whether it's your use case or not. Thank you.
Thank you very much, Vinci. So up now we have Peter from Cloud Guru to talk about serverless. do downstairs as well.
Cool. Thank you. Can everybody hear me at the back? Wow, this is packed house. Seriously, given the weather outside, I have to salute all of you for making the effort and being here. So thank you so much for being here. So look, my name is Peter Starsky, and I'm VP of Engineering at A Cloud Guru. Has anybody heard of us, A Cloud Guru? Wow, awesome! Whoa, I love you guys. I love all of you. And so, look, our mission, our purpose in life is to teach the world to cloud. So we produce awesome online courses on AWS, and a little secret, will be announcing new courses on Google and Azure very soon as well. But don't tell anyone just yet, between us. So look, my presentation here is about serverless and why I think it is the future of cloud computing. So a quick disclaimer, this presentation is supposed to take 40 minutes. I was told that I only have 20 minutes. So I have cut out a lot of slides and I'll go twice as fast as I usually do. So yeah. All right, oh yeah, that's the first slide. Cool. So this is me. I'm VP of Engineering at A Cloud Guru. I was the first employee at the company when I joined the two co-founders. And I've been with the company ever since, working on the platform and a lot of other things. I'm also the head organizer of ServerlessCon, which is kind of the world's only dedicated conference to serverless technologies. So we just finished our latest conference, which was in Austin back in April. And that was an amazing conference. We had speakers from Amazon, from Google, from Azure, a whole bunch of interesting companies, Adobe, IBM. All the videos are available on YouTube. If you go to video.serverlessconf.io, you'll get all the videos from that conference. A lot of fun. I highly recommend checking them out. I'm also the author of this little book, Serverless Architectures on AWS. You can see that I have spent way too much time on this serverless thing, way too much time. But look, if you end up kind of getting interested and you want to learn more, yeah, please check out the book. I think it's cool. So this is our website. So in just a quick I'll give you a bit of context about where we came from and why we think serverless is amazing. So back in 2015, we produced a few courses on AWS. So these courses were about AWS. We put them up on Udemy, and suddenly they went viral, and I've never seen anything like it. So people started loving them, started buying them, and it was a bit of a success. So we thought, okay, udemy.com is cool, we love it, but we think we can build our own platform, and we can make it very interesting and very social and very kind of engaging, so let's do it. So we started building this platform, that's our website, and we built the first iteration in about 4 weeks. So this first iteration had courses, had online streaming, user signups, e-commerce, payment processing, discussion forums, basically everything that a rich kind of interesting website would have. You could go on, you could buy a course, you could consume it, you could talk to other students. And so we did it all in a serverless way. And since kind of building our website and putting our courses, we have trained 200,000 engineers. I think that number is actually incorrect now. I think it's 250,000. So, those courses did become very popular. And the most interesting thing is that we are serverless. So we don't run a single server anywhere in the company. The only machines that we run are our laptops, nothing else. So everything is based on AWS Lambda. We use Lambda, we use API Gateway, we use DynamoDB, we use Firebase, we use Auth0. So we use a combination of these really kind of interesting, powerful services in concert together to deliver this kind of really powerful platform. And the most interesting, well, one of the interesting things is that for a long time, it was basically free for us. Because Lambda has such a big free tier, we didn't actually pay anything for Lambda. So we had hundreds of thousands of users, and like our hosting costs were nil, basically. I think now we are paying about $1,000 a month for our entire system. So that's for 250,000 users. And to me, that's amazing because I came from that traditional background where we had massive servers, data farms, and our bills would be just incredible. So this has allowed us to be really competitive with regards to kind of our competition. And there are other advantages. So yes. Yes, it includes DynamoDB. Yeah. So it's interesting, our structure, and I'll get into it a little bit. We use Firebase and DynamoDB, and the way we kind of partition our data is, and I'll talk about it. Oh, by the way, the best question will get a book. So.
Who says whether it's the best question or not?
That's true. Maybe you can choose. You can choose the winner. Oh, that makes it easy for me. No. That pizza smells delicious. So for those who kind of are saying, well, serverless, what the hell is that? Well, first of all, yes, there are servers behind the scenes, so I should just say that. Well, look, I see serverless as a number of things. I think it's a combination of these three things. So first of all, if you are serverless, you tend to use function as a service technology. So Lambda is an example of a function as a service technology. So basically what happens is, most of you know this, I'm sorry if I'm kind of repeating myself, but you write a function, you write some code, you zip it up, you deploy it to Lambda, and then Lambda executes that code for you on demand. And it can execute that code for you in response to an event, could be an HTTP request, could be an S3 event, something, right? It runs the code for you, and that code could be anything, right? It could be Python, it could be Node, it could be Java, C#. It's up to you. We have noticed that a lot of broad-scale, powerful serverless systems tend to use third-party services. So being able to execute code is awesome, but you may want to use other services as well. So for example, we use Auth0 for authentication and authorization. You may want to use Cognito. We use DynamoDB and Firebase as our database systems. That's fine. We use S3 for blob storage. We use API Gateway for a RESTful API that we've created, so on and so forth. And then thirdly, we realized that when you are creating these kind of serverless systems, there are certain architectures, certain techniques, which are very, very useful to know, and very useful to kind of, you should apply them if you're building a large-scale serverless. And I'll talk about a few of these architectures in a second. So I say that serverless to me is a theme, right? It's about using compute and patterns. And so this is interesting. So ThoughtWorks produces this technology radar every few months, and they kind of talk about what's hot and what's not in terms of technology. Kind of what should you be looking at, and what are the things that you can just say goodbye to. And it's interesting that this is the latest technology radar from ThoughtWorks, and they put serverless architecture under trial. So they're basically saying that it's getting really kind of mature and really serious, and you should maybe start looking at it if you are building large scalable systems, or maybe even if they're small systems. It doesn't really matter. I want to make a small point. I don't know how much time I have left. Let me just check. I think I'm good. Yep. I want to make a special note about Lambda. So I mentioned that Lambda is that technology that will execute code for you on demand. Lambda is not the only game in town, right? There's Azure Functions. Has anybody used Azure Functions? Yeah, that's about the response that I usually get. I hope nobody's here from Microsoft. Is this filmed?
Who's here from Microsoft?
We'll delete that. We'll edit that out. I love the Azure Functions. Is great. IBM OpenWhisk. Yeah. Google Cloud Functions. Yeah. All right. Well, anyway, they are all alternatives to Lambda, right? And they are awesome services, and they can do certain things that Lambda cannot. For example, the debugging experience with Lambda is so-so. It's actually pretty crap. It's actually better if you use Azure Functions that has live debugging where you can kind of look at your stack trace and see what's going on. And Google Cloud Functions has awesome live debugging. OpenWhisk integrates with Watson, which is kind of cool. But anyway, so Lambda is this awesome service, right? It will execute code for you on demand. And what's interesting is that we've realized that Lambda is to compute what S3 was to storage. So if you think about it, when S3 came out, I think it was about 2006, and we were all much younger and happier, and it was awesome. It still is. But you could take a file, you could push it into S3, and you didn't care for storage capacity, right? You didn't care. There weren't any drive sizes. There was no such thing as too much unused capacity or not enough capacity. It would kind of scale for you as you needed the service to scale. And a lot of headaches were kind of dealt away with. So Lambda is kind of similar if you think about it. It's the same thing but for compute. You give it some code and it will execute it for you in that elastic, scalable manner. And you don't know where or how, it kind of just does it for you. So now you can actually think about the architecture and the code a lot more rather than that kind of underlying low-level technology. You don't have to think about provisioning VMs or scalability groups. You can now focus on code and architecture. And kind of as we built our website, we came up with these 5 principles of serverless architectures. And they are actually captured in this book.
Shameless plug. Good work.
I was trying to be so subtle. Failed. But anyway, so these 5 kind of principles, I want to kind of illustrate a couple of those principles and give you a few examples if you are thinking of building your own serverless application. And again, look, you can design and build a massive scalable system like we have that supports, my God, something crashed, that supports a lot of users and does a lot of data processing, or you can build something small, right? You can design one little Lambda function to do something small. You don't have to go big from the very start. But I guess this was the primary kind of driver for us. Use a compute service to execute code. So we don't have any EC2 service. We just use Lambda when we need to execute custom code. So here's one simple architecture. I mean, for most of you, I think you'll easily recognize what this is. So you have your client, you have your API gateway, right? That allows you to create your RESTful interface. You can connect a number of Lambda functions to that API gateway, and those Lambda functions can talk to other services or to other Lambda functions. So suddenly you can create this very scalable backend. Because API gateway will spawn as many functions as you need within certain limits to handle all the incoming requests coming into your system. Yeah, there are limits, so please have a look at the documentation, but you can always call Amazon to leave those limits. Usually you want to look at the number of concurrent invocations that you're causing. You may have some limits initially on your account. But yeah, you can create this very scalable backend by kind of combining services together. Another architecture, I call this computer's glue, is about using Lambda to glue various services together to create powerful kind of pipelines. So here we have, an S3 bucket, and you can wire it up to a Lambda function, which will kind of trigger and fire automatically whenever a file is placed into an S3 bucket. And then that Lambda function can talk to other services, which will then in turn trigger other services, so on and so forth. So we've discovered, and I think a lot of you have discovered, that you can build these very powerful, impressive pipelines really quickly, really cheaply, and they can do a lot of things for you. I'll give you an example of what we've done. So, push-based event-driven pipelines. So before I get kicked off the stage, here is a very simplified version of one of the pipelines that we have in our system. So with us, you can we allow our lecturers, our instructors to log into our system and then upload videos that they have created, right? So let's say there's the CSA Pro course, the lecturer comes in, he's got a new video, he or she, they have a new video that they have created. They upload it through our system. That video gets transcoded to like 12 different formats, like 720p, 1080p, HLS, WebM. So different formats, different bit rates for different kinds of consumers. And so here's what happens. So a user, instructor goes in, uploads a file straight to an S3 bucket. So there's no server in there. This happens from the browser straight to an S3 bucket. That kicks off a Lambda function. Lambda function goes to the Elastic Transcoder, which is another service in AWS, which allows us to create these different versions of the file. Elastic Transcoder does its magic, creates these 12 different versions with different bit rates, and puts them into another S3 bucket. That causes a message to be pushed onto an SNS topic. That stands out and launches in basically runs other Lambda functions that we have. One of those Lambda functions goes, hey, there's a bunch of new videos in the second S3 bucket. That's awesome. Let's go and update our database. This is Firebase. So Firebase is Google's real-time streaming database. And what's cool about it is that it automatically pushes out updates to all the connected clients in real time. So let's say you're looking at our website. We make a change to Firebase, and Firebase, using WebSockets, will push out an update in real time to you. It's kind of awesome. So here, Lambda makes a change to Firebase. Firebase basically pushes out an update to all the users currently connected to our website, and they see new files appear in real time, just as soon as they have been transcoded. So you have these kind of event-driven push-based pipelines, end-to-end, no user kind of input apart from that very first upload. So you can do really cool things like that, and it's mind-blowing. Yeah, I love it. Some of the cons, look, we think it's awesome, but I do realize that it's not a silver bullet in all use cases. Lambda itself has a number of limits. A simple one is the 5-minute timeout, so your Lambda function will stop working after 5 minutes. So if you want to do a lot of processing, if you have a large task that you need to process, you need to parallelize, right? So you need to do it in parallel. You may have to implement a version of serverless MapReduce, but maybe it cannot be done. Somebody approached me with a question about virtual reality recently. So they're doing something with Lambda and VR, and they are rendering scene, but they cannot decompose the scene in a good way. And then render components of that scene in Lambda because of the algorithm they're using. So sometimes you have to think outside the box. Yes?
Sorry, Peter, I want to ask you, I believe you guys installed.
We didn't use beanstalk. So we actually used, before Lambda, we used Auth0 web task, which is the kind of another kind of fast function as a service technology. And so we used that, but when API Gateway came out, so this was before API Gateway, we transitioned to Lambda and API Gateway. Yep. Yep. So the question is, if we had access to step functions when we were kind of implementing a Cloud Guru, would we use it? Are there any advantages? The answer is yes. I think we would find a few use cases for step functions. Step functions are fantastic in a way that they allow you to chain multiple functions together and have things like retry, logic, loops for you done automatically. So there are certain things that we kind of had to do manually, especially with, say, retries and exponential backoff, and yeah, it was a little bit messy. If we had step functions, I think we would have used it. I know that the Nordstrom team, for example, so Nordstrom is a big company in the US, they sell things. They love Lambda, and we think they are awesome. They have an awesome team. And I remember that when AWS announced step functions, they were like, hooray, we can now use step functions, because they had to kind of implement their own version of step functions, because they had these complex pipelines and steps that they had to kind of implement themselves. But yeah, so absolutely, I think we would think about using step functions.
How about Lambda, so serverless general and testability, like component test, end-to-end test, the serverless world? I find that hard to get my head around.
Yeah, so I think testing is one of the bigger problems.
Read the book.
Well, you know, you're choosing.
Sorry,
yeah,
that was
yeah,
a
yeah,
joke.
yeah. No, well, yeah, it's good. Well, look, it's a great question. I do actually talk about testing in the book. So look, I think the functions themselves are not hard to test, because at the end, you know, let's say a function is just node, you know, you can just test it, right? It's not very hard. I think
unit test server, right?
Right, exactly. Yeah, exactly. You can mock other things, but it's kind of that integration level testing, right? It's testing everything, because suddenly, if you move away from your kind of familiar monolith that you have always built, for example, and you go with this serverless approach, you suddenly have this big distributed application, right? You basically you have built these microservices in a way that talk to one another, all these third-party services. So then, how do you have a kind of an overview of your whole system? How do you test it all? How do you test all those components independently and in concert? It becomes, but it's kind of the same challenge that you get with microservices. You know, whether you have them implemented using Docker.
Well, I can, sorry, we should maybe take that offline, but I can bring microservices up, like in a container or so, and I can use peg tests or whatever to, which...
True, and you know, with functions, we use serverless framework, for example, and serverless framework allows you to run functions locally on your system as well. Our company is actually working on another project at the moment, which is serverless Docker. So basically, it allows you to run a function in a Docker container as well, locally, for testing as well. And it accurately kind of tries to recreate the AWS environment, including all the resources. So, but we can talk about it offline. Am I out of time, or do I have 2 minutes?
5 minutes.
5 minutes? Awesome. I'll be even quicker. So look, not for everyone. Yeah, absolutely. Service level and customization. You know, you choose a managed service. You have to live with what they offer you with the right service level. There is that thing about vendor lock-in. It's a common question that I get asked. And to me, the vendor lock-in is not in using Lambda. Actually, porting Lambda functions across is very easy, right? Just, you know, you can wrap the Express framework around it and run your Lambda functions on your own server, or you can move to Azure functions, not a big deal. The hard problem is moving all the other services that you may be integrating with somewhere else. So if your functions integrate with Dynamo or S3 or something else, how are you going to move those other services? That will be a challenge, I think. And of course, you have now a decentralized system, so you have effectively created this wide distributed scalable system, but debugging, tracing becomes a bit of a challenge. Although with X-Ray, a new service from AWS, it's a little bit easier. Pros, obviously normal service to manage array. I'm a developer, I'm bad with hardware, I don't want to patch anything, so for me this is amazing. Versatile, lower cost, less code, scalable and flexible, and like, you know, we have some statistics and some kind of guidance that we can give on all of this. We even came up with a serverless calculator. So if you go to serverlesscalc.com, it's a calculator that allows you to kind of see what running a serverless system will cost, right? You say, this is how many requests a month my system will handle, this is how long my requests on average will take to execute, and then you'll get a cost from, you know, from AWS, or if you do it in Azure, or if you do it using Google, you'll get costs for all those platforms. Really quickly, so we kind of implemented our website. It was awesome. It was worked very well. But we've realized that we implemented a serverless monolith. Because what we effectively had, we had one database here, Firebase, and we had all these kind of Lambda functions that would write to this database. So if you think of a microservice, right, it's actually a service with its own kind of unique, isolated business context, its own data storage. And we didn't have that. We had one central database. So we started kind of refactoring that because our team is growing and we want teams to work in parallel at the same time, not step on each other's toes. So we kind of started refactoring and creating true microservices. So here what we have is this. So this is what we have now. Let's say a request goes to the API gateway. That API gateway can invoke the required Lambda function. Lambda function writes to a DynamoDB table. And then a trigger on that DynamoDB table goes and updates our Firebase. So it's funny that we implemented this. It's basically a form of CQRS, right? So Firebase now works as our materialized view, which powers our website, right? It's just basically a dumb view. Just has enough data to, put things on our internet. Then we have DynamoDB here. So each service has its own DynamoDB table or tables. And then of course we have data in Redshift and other places for analytics and reporting. But the cool thing about this is that we've been able to kind of refactor our serverless monolith into, serverless microservices without having to provision any infrastructure, any hardware, create any service, decommission anything. We could just modify our serverless scripts. So we use serverless framework and we could just modify our scripts and the way our code worked a little bit and deploy. And we could have this whole new kind of system up really quickly. One other thing, managed services are moving targets. That's something to be aware of. Lambda worked with Node.js 0.1, then they said, sorry, we are killing it, so no more Node.js 0.1 support. So we had to migrate off 0.1 to 4.1. Auth 0 once introduced a bug into a component that we use. And because we use Auth 0, we had that bug on our website. So obviously, if you do use managed services, you have to be aware of that they can have an impact on you. If you want to watch the videos, and I highly recommend because they are super interesting and super entertaining, go to video.serverlessconf.io. That's the YouTube channel for our conference. Unfortunately, this URL is wrong. I'm sorry. So you can just Google for the title. I'm sorry, I made a mistake. And of course, check out our website. I have good news for everybody. Everybody who's here today will get a free course from A Cloud Guru on serverless architecture. So you get a course and you get a course. Yeah. I think our organizers will send an email after today's
something out.
Awesome.
Yep.
Yeah, and you'll get a link, so you can just click and get the course, and it's awesome.
So you have to have signed in. Did everyone sign in when they came in? And yeah, okay, cool.
Please sign in. Those courses are awesome. We also run in-person. Sorry, it's a last slide. I promise. We run in-person workshops as well on serverless architecture. So if you're interested to know more, please let me know. And thank you very much.
Awesome. We'll take a couple of questions. We've got 2 questions, just to make sure it's not his questions.
How do I keep AWS Lambda warm? It's not an actual issue for us because we have this constant we have users constantly on our website kind of hitting Lambda. So for us, it's not really a big deal, and we don't really see containers go cold very often at this stage. If it was a problem, we'd probably have a timer that would kind of invoke our Lambda function from time to time to do more. Yeah.
One more question?
Serverless will kill everything. So the question was, will serverless kill the traditional?
Is that in the book too?
That's in the
On the first page.
On every page. on every page. Yeah, I think we'll change the way we do testing. Absolutely. I'm pretty confident that there will be new services coming out that will allow you new services and software that will help you test serverless applications. We can talk about it later. I have a feeling that like serverless framework, those guys are working on something to do with CI, CD, and testing. That could be coming out. But yeah, look, absolutely, it will change. But we can talk about that as well.
Thank you very much, Peter.
Thank you.
You're sticking around.
I will stick around.
If you have more questions,
You have to want to go.
yeah, I'll give this guy.
Thank
There
you.
you go, Dan. Well done. Cloud Peter, thank you very much. That was an amazing talk. Stick around to talk about serverless, grab some pizza, and we're coming back for another session in about 15-20 minutes. Thank you.